Hello everyone, welcome to Mifratech. So today in this section I am going to explain you hard disease prediction project. So in this project mainly we are going to predict whether the person has the heart disease or not using different kind of machine learning techniques and algorithms. So how to run this project and what is the exact output you will get in this project I have explained in the previous section. So now in this section I am going to explain what are the exact algorithms we use and what is the data set we use, how we trained the algorithm, what is the accuracy we got, all those things. The backend code I'm going to explain in this section. First we'll go to the project folder and what and all the things related to backend code I'm going to explain it. So here this is the project folder, hard disease prediction. So here the backend code is hard disease prediction final. So this is the exact backend Python code we have written, and this hard is the exact data set we are using in the project, and hard disease pkl, that is the file which give the more accuracy, which converted into a fickle model. This is what the generated thing here. So now first before starting to the project, like explaining this one, there are certain packages needs to be installed in this one. So how to install that one means, so what we have to do means, in order to install all those required packages, just go to the search bar there and type cmd there, command prompt. Just open, double tap this, the command prompt will open. Now again go to the project folder. So here open the requirements text file. So I told in this one what are all the required packages both for front end and back end I have written with the versions here. So these are the different packages now I need to install. So how to install means, so now you go to, we have open the command prompt. Now we have to go to the exact directory or path where the Python has installed in my system. So for that, go to the file manager and go to C drive, local disk C. In that one, go to program files, Python 36, and inside that there is a script. So this is the exact path you have to copy. After copying, go to just command prompt and type cd here, that is change directory. Paste that path, click on enter. Now path has been changed where exactly Python is stored inside my system. So now the command is pip install numpy hyphen user. So this is the exact command you have to install in order to install the different packages. Now installing numpy package required for the project, and here in order to, when you are installing for the first time, internet is required here. So after clicking on enter, it will start downloading. After that it will show successfully installed, but in my system this package is already installed, so now it will show requirement already satisfied message now. So now see, after it is showing requirement already satisfied, the next thing what we have to do is one more next package we need to install. So how to install means, the same command you have to use, just the type of the package name you have to change in the command. So now go to, in the place of numpy, just you can type now pandas. This is the next package required. So pip install pandas hyphen user. So now it will install the at one. So requirement satisfied, nothing but it is already there in my system. So next package is numpy pandas over skykit-learn. So skykit. So now we have to install one more package, that is pip install skykit-learn. So the command is pip install, type skykit-learn, and here if you want to install any specific version of the like package means, then you go to the text folder, the requirement.txt here. Observe here, flask, numpy, pandas, matplotlib. You can install any other like version also, it will, latest version also it is acceptable. So but PyMySQL and scikit-learn, you have to install this package only, this version only particularly, because these are packages I have used in the program. So if you want to install the exact version, just copy this line scikit-learn 0.22 version and go to the, after copying, go to command prompt. Here after pip install, the place of scikit-learn, just copy paste that one, whatever the link is there. So here the command, so just copy that one. So now it will show, see, pip install skykit-con with the version hyphen user. When you click on enter, it will start downloading. So it is already there in my system. You'll get a message there. See, it will show requirement already satisfied message now, because the particular skykit package is already present in my system. So now next thing is we have to install matplotlib. So how to install it means, just type pip install matplotlib hyphen user, click on enter. So it show requirement already satisfied, so because it is already there in my system. So next package we required is uh, matplotlib over. Next thing is pip install. I have to enter flask, so flask flask hyphen user, click on enter. So requirement already satisfied because it is already there in my system. So next thing is PyMySQL we have to install. For that the specific version only have to install. Just go to requirement.txt file and here just copy this exact line and go to the command prompt and type pip install the PyMySQL with version hyphen user. Click on enter. So it will show it's already there in my system is because it will show requirement already satisfied. So now all the different packages required both for front and back end have installed now. So you can see Flask, NumPy, Pandas, Matplotlib, PyMySQL, Scikit-learn, all the packages I have installed. So now just close the command prompt and also close this requirement.txt file. Now go to the project folder. So which is the file related to backend code? I already told hard disk is prediction file. Just open this one. Just click on right click on this edit with. So it will show. Uh, So we'll open with edit with ideally, just a minute. Yeah, click on edit with ideally, edit with 3.6. So it will open the code now. So now I have just opened my uh, front end code now. Sorry, that back end code where we train the algorithm, all those things will be present inside this Python file. So now the first step what we have to do means whatever the different packages we are using in this particular program, we need to import it, import in the program. The first step we have to do. So how to do that one means just go here first import numpy as np. So what this line will do means this is exactly going to import your numpy library required for the project and storing as alias name np. So why exactly numpy is required means, so if you are using any n dimensional array or using any kind of mathematical techniques means all those things available inside the numpy library. So just I'm importing now. So next thing is import pandas as pd. So what this line will do means, so in here I'm importing pandas library and storing as a alias name pd. So here in order to load whatever the data set we are using in the project, in order to load the data set and in order to check is there any null values, is there any duplicate values, in order to check how many like rows is there, columns is there. So in order to analyze anything related to database or like data set, all those techniques are available inside the pandas library. So I'm importing this one. So next thing is in this project we are going to draw some different kind of plots here, like like two different graphs we are going to draw in this project. So in order to draw those graphs, we need some packages which will help us to draw the graphs. So what is those things means matplotlib and seaborn. So that you have to import. So import matplotlib.pyplots as plt. After that import seaborn as sns. So here one thing I have missed out. I have installed matplotlib in command prompt seaborn, but I missed out while installing. So what you have to do is just go to command prompt again. So after going to command prompt, so now command prompt open, go to the path folder where the python is again, copy that path and go to type here cd and paste the path. Now after going to particular path python install, type command pip install the package. Now I have to install is seaborn, seaborn. After that type hyphen user, click on enter. So in case if you have missed any packages miss, those things need to be installed. So now seaborn also installed. And one more packages I left is xgboost. So here we are using xgb classifier algorithm also, that needs to be installed. So how to install means pip install the type, you have to type xgboost. So this is how you have to install. So after click on enter, these things I have just missed them. So now you make sure these two need to be installed, this one, or we can again add that these things in the comment in the requirement.txt. Update here seaborn, and one more thing is xgboost. So just save this file because I just missed them. So now I installed all the things required. This xgboost and seaborn I left out, those things also installed in the command prompt. It is already there showing requirement satisfied. Now close the command prompt, go to the project code now. So what are the packages required in order to draw graphs is import matplotlib and seaborn. Just I have imported import matplotlib.pyplot as plt, import seaborn as sns. Next thing is while you are executing the program, if you are getting any kind of warnings means we need to ignore those warnings. So how to ignore the warnings means import warnings, warnings.filter warnings of ignore. So these two line will do that purpose. So while you are executing the program, if you are getting any kind of warning means just these two lines will help us to ignore those warnings. So next thing is what and all the different techniques and algorithm we are using from the sklearn we need to import. So from sklearn.model selection, import train test bed. So whatever the data set we are using in the project, the whole data set will not use in order to train the algorithm. What we will do is either 80% or 70% of data will use for training and remaining 20 or 30% will use for testing. So in order to split the data set either in the ratio 80-20% or 70-30%, we need a technique. So the technique is train test bed, that is I am importing now. So from sklearn.model selection, import train test bed. So now whatever the algorithm we are using in the project, first we need to import them. So from sklearn.linear model, import logistic regression. So now I'm importing logistic regression. So here in this project, so this the project will come into classification category, because in the final we have the person has the heart disease or not, only two output we'll get. We'll call it as classification problem. So in order to solve this kind of machine learning problem, we need to use classification algorithm. So whatever the classification algorithm were there, I'm going to import them. So from sklearn.linear model, import logistic regression. Next from sklearn.ensemble, import random forest classifier. From sklearn.neighbors, import k-neighbors classifier, that is nothing but knn algorithm. From sklearn.naive, I'm importing Gaussian naive Bayes, Gaussian NB. So from sklearn.svm, import svc, that is support vector classifier. Next from sklearn.tree, import decision tree classifier I'm importing. Next from XGBoost, we have to import XGB classifier. So different 7 classification algorithm just now I imported in this project. So next thing is, once a model has been trained, we have to predict the output from the trained algorithm. Next we have to check the accuracy of the model. So how to calculate or check the accuracy of the model means from sklearn.matrix, import accuracy score. So with the help of this accuracy score only, I'm going to predict the calculate the accuracy of each trained algorithm in the later section of the program. So now up to now what I've done is just imported different packages required for the project here, just imported them in the program. So next thing is, we have to load the data set to our program. So before loading, what is the exact data set we are using, I'm going to show you now. So the file is hard. So this is the exact data set we are using. Just double click on this, the data set will open. So here whatever the data set we are using, the name of the data set is hard and it is in the extension CSV, that is nothing but comma separated value. So now you can observe what and all the different parameter present in this data set. The first is age, next is sex, CP, test base, call. So these are the different parameter related to heartbeat is present in this data set, and target. So this is target our result column. Here 1 means the person has the heart disease, 0 means the person not have the heart disease. So this is how the data set is there in my data, these are the values present in my data set. This target is my output column, except the target column, the remaining all are my input columns. So here this is the exact data set we are using in this project, and you can observe there are 3 rows of data values present in my data set. So now what I will do is I will close this data set. We'll go to program again. So in the program, I told we first thing is, next thing what we have to do is we have to load the data set to the programs. How to load it means, first here whatever the data set I just now shown you the data set in the extension CSV, that is comma separated value. So if you want to load anything which is in the CSV format, the command we have to use is read underscore CSV, that is in order to load any kind of file which is in the CSV extension. So now I'm loading, that is available in pandas library. So read underscore CSV, load the dataset. So the name of the dataset you have to give within the braces, that is heart, the extension is CSV, comma separated value. So finally enclose within single or double quote. So this line will load your dataset. I will store in a variable data. So now I will print my data. So print of data dot shape, what this line will do is it is going to print number of rows and columns present in your data set as a output. So after that, here what each column is, there's meaning of each column I am going to print as a one by one after one, whatever the different column present in my data set, what each column means that description I'm going to print now. So how to print means, first I'm going to create one list. So the name of the list is info, inside that one each column values I'm writing. First is age, next value is 1. Here in the sex column, 1 means male, 0 means female, one more is chest pain type, means there are 3 types of chest pain. What is 1 means value, if you enter 1 means that is typical angina, if you are entering 2 means that is atypical angina, 3 means that is non-angial pain, 4 is asymptomatic. So if you're entering any values between 1 to 3 4 means what those means I have written here. Next thing is resting blood pressure. Next, serum cholesterol in mg per dl value you have to enter. Whether fasting blood pressure, whether it is greater than 120 mg per dl, that is 0 or 1, true or false you have to write. Yes means 1, no means 0. Next is resting electrographic result, values in between 0 to 1 2 you have to enter is 0 1 2. Next, maximum heart rate is achieved, that value. Exercise induced angina, old peak, that is ST depression induced by exercise relative to rest we have to enter. Next, the slope of the peak, exercise ST segment. The number of major vessels in between 0 to 3, that is colored by fluoroscopy you have to enter. Next, thalassemia, the disease in which stage, so it is normal means 3 you have to enter. If it is a fixed defect means 6, 7 means reversible defect. So these are the information about each column in the data set. So now I want to print them one by one after the other. So what I will do means I will for loop I will create. So for I in range of length of information, so what I am doing, I am fetching these information one by one using for loop. I will store in a temporary, so length value I am fetching. According to this one, I will print those data set from the data set. I loaded data set. So print of data dot column. So what this will do is it is going to give the list of number of columns names present in the data set. Each column name I will print one by one. I am using according to this one. Whenever each column name is printed according to that column name line only, after a 3 task space I am going to type the information, whatever the information is there in this information list. So that is what I am doing here. So after executing this line, that is the kind of output you will get in this project. So next thing is print of data dot column. So what this line will do is it is going to give a list of column names present in the data set. So next thing is print of data dot head. So what this head of function will do is it is going to print number of like starting 5 rows of from your data set starting from index 0 to 4 by default. If you want to enter more number of data means inside this head function type number of rows you want to print from the data set. If you typing 17 means 79 data set, it will print rows of data. 90 means 90 rows of data from your data set. So that is how the head function will work. By default it is going to print starting 5 rows of data from your data set. So next thing is print of data dot describe. So what this function will do means it is going to describe function will give the statistical description about each column in the data set, like what is the count value, what is maximum, minimum, standard value, like this some statistical information about each column in the data set you are going to get as the output there. So next is print of data dot core of function. So what this core of function will give means it is going to give correlation description about each column in the data set, like a table, like how each column is correlated with each other, some value you will get in between -1 to +1. So next thing is, in case in your data set is there any duplicate values present, we have to drop them. So how to drop means data dot drop underscore duplicate. So this drop underscore duplicate function will help us to drop any kind of duplicate values present in your data set. So after dropping I will store it in a variable data now. So now I have dropped the duplicate values, but I don't know whether they have been dropped or not. In order to cross check, what I will do is I'll print the data shape again. So print of data shape will print again the number of rows and columns present. Initially also I have printed, now also I am printing. So if I compare both, I will get know whether is there any reduction in number of rows or not. So next thing is, in your data set is there any null values present, means we have to drop them. So how to drop those null values means first we have to check is there any null values. So how to check means print of data dot is null of sum of. So what this line will do is it is going to give in each column how many null values present, the count value you are going to get as a output there. So in case null values present means we have to drop them. So how to drop them, is data dot drop now. So this function will drop any kind of null values present in the data set. So after dropping I will store it in a same variable data. So finally, in order to cross check is again null values is there or not, I am going to print of data dot is null of sum. So it is again will print is there any null values present in the data set or not. So up to this much I am going to show you the output now. So click on run here, click on run module F5 in order to run the program. So now we have to wait for some time, because if we are doing for the first time it's going to take some time. So now see here, whatever the output I showed. The first is a print of df.shape. When you print that one, the number of data.shape, number of rows and columns present in your data set, it will print. So there are 303 rows and 14 columns entirely present in your data set. So next I printed the description about each column in the data set. So it is printed now. See the age column, age value will be there. In the sex column, 1 means male, 0 means female, like that. GP chest pain, what are the different chest pain type is there. One means typical angina, like that, some information like that. In each column, what is the description about each column I have printed there. After the df dot column, so the column names present in the data set, so those as a list you are getting. So here this is for data dot columns. So next thing is data dot head. For the this is the output. So starting 5 rows of data from your data set, it is printed starting from index 0 to 4. So next thing is data dot describe. For that this is the output. What is the count value, number of rows present, mean value, standard deviation, maximum value, minimum value. So some statistical description about each column in the data set you got. So df dot data dot core of function, that is correlation function output. This is the output. So how each column is correlated with each other, like age to age column the value is 1, like that. How age to cp, what is the minus 0.06, like that. How each column is correlated with each other, the correlation value will get in between -1 to +1. So next thing is I drop the duplicate values. I again check the shape of my data set. It is showing 302 rows, 14 columns. So initially it is 303 rows. After dropping the duplicate values, I got 302 rows. That is nothing but there is one row of data was the duplicate value, so it has been dropped now. So after that I check is there any null value. So you can check here all the values, column names, it is showing 0 is nothing but there are no null values. In case present also I dropped, I again check the null values. Now also it is showing no null values present in the data set. So next next thing I will these are the output, like output of how much our expand the program now. So now I'll proceed with the rest of the program. Now next thing is I'm going to draw two different graphs here. So one is here in my data set there is a target column I already showed, that is my output column, where one means the person has the heart disease, 0 means the person not have the heart disease. So in my data set in the target column, how many ones and that is how many person has the heart disease, how many not has the heart disease. For those values I'm going to draw one. So now I told like how many ones and the zeros, that is number of persons has the disease, not have the disease. For those values I'm going to draw a bar plot here. So how to draw means first data of the column, which column I'm drawing is for target column, dot value underscore count. So what this function will give me is how many number of ones and zeros present in this target column, that value I'm going to get as output. For those values I'm going to draw the plot. So dot plot of, so which kind of plot I will do, means bar plot. So kind I'm giving bar. Color, so as there are two values 0 and 1, two colors I want. So color salmon and light blue I'm giving. You can give whatever the color you want. Finally for the heading of the x label I'm giving, for the x label some information I will add, that plt dot x label. 0 means no disease, 1 means one disease, 1 is equal to disease I'm adding just to inform the user. This you can add as additional information in the x axis. Next the title of the graph I'm giving heart disease here, plt dot title. Finally to show the output, or you can see in order to show the output just type plt.show, it will show the graph output there. So next there is one more graph I am drawing, that is for the like among the how many person has the heart disease and not has the heart disease, among them how many females have the heart disease, how many males have the heart disease, like that also I'm going to draw a plot now. So pd dot cross tab, so this is the type of the graph I'm drawing. For that which value means data dot for target column and again data dot sex column. So these are the for two values x axis and y axis I'm going to draw the graph now. Plot, so which kind of plot I'm drawing is bar plot. The size of the figure you can manually give. I'm giving height and width in 6, color salmon and light blue. So finally title of the graph I'm giving plt dot title, hard disease a frequency for sex. So next plt dot x label I'm drawing, 0 means no disease, 1 means disease, plt dot legend. So here which color will represent what, in order to mention that one I'm going to give the add plt dot legend there. For that female and male is the legend values I'm adding there. So finally to show the output, graph output, I'm drawing plt.show. So next thing is in the entire data set here which like whatever the our output target column is there, whatever the remain input column is there, that input and output column we need to assign to some variables now. So first in my data set target is our output column, so that I'm going to assign to some new variable now. So data dot target. So this column I'm going to assign variable y. So y is equal to data target. So my output column present in variable y. Now what I will do is I will just drop this from my original data set. I will left with only input column that I will assign to one more new variable. So data dot drop, I am dropping my output column, which column is data dot drop of target column. So next this drop will take one more parameter, that is access. What is access means we need to mention whether whatever dropping which is a column or row. So access is equal to 1 is nothing but I am dropping the entire column, which column is target column. So after dropping I left with only input column that I am going to store in a variable x here. So now I assign my output column to y, input columns to x variable. So next we have to split our data set. So how to split means with the help of train test split I'm going to split my data set. So now I'm calling this technique. So train test splitter, the first parameter I'm passing is x, that is my input columns, y that is my output column. Next a parameter, next is test size. So what is test size means like in which ratio we have to split our data set, that ratio you have to give. So 0.2 is nothing but 20/80 ratio to split. If you give 0.3 means that is 30%, 0.1 means 10%, like that we have to give. So test size I'm giving 0.2 is nothing but 20/80% ratio to split the data set. For test size it will take 20% of data. So random underscore state, one of the next parameter this train test split will take, that is nothing but number of times shuffling the data. That value I'm giving 0 is nothing but it is not going to shuffle the data. So finally after executing this line you are going to get 4 different output. So that I'm going to store in 4 different variables x train. So in this variable 80% of my input data from input columns will be stored in x train, remaining 20% of data will be stored in x train. Like that from output column y, 80% will be stored in y train, remaining 20% will be stored in y train. So this is how exactly the splitting is done. But now the splitting is done in the 80-20% ratio, but you don't know exactly 80% means how many rows, 20% means how many rows it has taken. So in order to cross check, I will print the shape of each variable now. So print of x train dot shape, x train shape, y train shape, and y test shape. So finally it will number of rows and column present in each these variables. So now up to this much I'm going to explain you the output. Just run this program again, run, click on run module F5. So once the program is done, I will explain you the output up to this much, whatever the just now I explained. So up to this much I have explained. After that drop will generate, I told. So now the graph is generated for the number of according to target value. So now you can observe in this graph the title have given R disease. In the x-axis have written 0 means what 0 means it is a no disease, 1 means the disease. So here how many number of ones and zeros present in the the count value is present in y-axis, and 0 1 is present in x-axis. Now you can observe there are around 160 something number of persons have the R disease, and nearly there are 130 something person not have the heart disease. So this is the graph you are getting here. So here there are different options available in graph. So here there is a left and right button arrow mark is there. This is in order to like move the graph here. So there is a zoom button. When you click on this one, say like this, if you select you can zoom that button here. So next if you want to save that as an image means there is a save button. When you click on this one it will take you to file manager. Now you can save this graph as an image there. So these are the different options is there. So now if you want to go to normal position means there is a home button is there, just click on this, it will go to normal view. So now this is what the graph generated. Now if you want to the now if you want to load like execute the rest of the program is this graph need to be cancelled. After that only the rest of the program will continue. Just close this one. So next one more graph will generate, as we drawn one more graph for the number of how many females have the heart disease, how many males have the heart disease, like that in order to predict. For that the graph heading have given title heart disease frequency per se. In the exercise have written 0 means no disease, 1 means disease. You can observe here there is here what red color and what that is salmon and blue color will represent. We have mentioned here salmon color means female, that is red color, blue color means male. That is what here you can observe how 0 means not having the disease, 1 means having the disease. Here there are out of 160 there are 114 something person males have the heart disease, like not have the heart disease. Among females 24 not have the heart disease, like among male 92 have the heart disease. Around 70 something persons like in the female not have like uh, have the heart disease. So this is what the exact project like graph you are going to get for this one. So there are same options available for this graph also, you can save. So now in order to proceed with the rest of the program just you need to cancel this graph. So now I will cancel this one, so it will proceed with the rest of the program. Now after that I splitted the data set, I printed shape of x train like that. So now you can also observe the shape of x train is there are 241 rows and 13 columns present in my data set. Nothing but out of 303 rows to 80% means 241 rows it has taken, and 13 columns is there because except the target column we left with only 13 columns. In next test means 20% means 61 columns it has taken out of 300 rows on 13 columns. White line means 241, nothing is there means only one column, that is target column. X test also 61 column, nothing is there means one because target column. So this is what the, this is how the splitting has occurred now. So next thing is we have to like what we have to do is whatever the different algorithm we imported, we have to create like object of each algorithm now. So logistic regression of open and closed brace will create an object of logistic regression. I will store it in a variable now, which variable means model 1. So here onwards model 1 is nothing but my logistic regression. Next, random forest classifier of algorithm I am calling, this will take one of the parameter random underscore state. So the here this random state value I am giving is nothing but number of times shuffling the data. This is one of the parameter random forest classifier will take, that value I'm giving 285. So now I check that giving different values. So for these values I'm getting the maximum accuracy, so only I'm keeping the value as 285. You can give any value 1 to like 500 1000 anything values. For this value only you will get the more accuracy. So now I'm keeping 285 and 1673. For these values only you will get the more accuracy. So next thing is I will store this random forest in a variable model 2. Next, k neighbors classifier. So knn algorithm I'm calling, this will take one of the parameter, that is n neighbors, that is number of nearest neighbors required to predict the output. That value I'm giving 9. So you can give 5 7 9 any values. For that I'm just keeping 9 because for this value I'm getting more accuracy. Next thing is that knn I will store it in a variable model 3. Next, decision tree classifier and object creating stored in the model 4. Next, Gaussian naive, one more object I'm creating stored in model 5. Next, svc, that is support vector classifier, this will take some of the parameter I'm tuning, that is kernel I'm giving linear. So c value, that is learning rate, I'm giving c is equal to 10 here. Gamma, that is also one of the parameter this svc will take, that I'm keeping 0.009. For these values I'm getting more accuracy from svc, so I'm keeping these values as parameter as final. So for that I'm giving storing in a variable model 6. Next, sgb classifier and object creating stored in a variable model 7. So from model 1 to model 7 all the 7 classification algorithm object have created. So next thing is now we have to train this algorithm. So how to train means model 1 dot fit xtrain dot ytrain. So what this fit function will do means it will help us to train the algorithm. Which data I will give in order to train means xtrain ytrain, that is only 80% of training data I am giving in order to train my algorithm. So model 1 is nothing but logistic regression, so this line will train the logistic regression. Next, model 2 dot fix xtrain train. Model 2 is my random forest, it will train a random forest. Like that from model 1 to model 7 all the 7 algorithm I have trained here. So after training, next we have to predict the output from the trained algorithm. So how to predict means model 1 dot predict. So this predict function will help us to predict the output. So for prediction, which data I will give is x test, that is nothing but 20% of my input data which I kept for aside in x test, that is I am giving as an input. Now to predict the output, for this input data it will predict the output, that I will store in a variable ypred1. So this is from the predicted output from logistic regression. Next, model to predicted ypred2 random forest. Like that I will store predicted output from all the 7 algorithms starting from index variable ypred1 to ypred7. So now I trained the algorithm, also predicted the output from the trained algorithm. Next thing is we have to check the accuracy or calculate the accuracy of each algorithm. So how to calculate means the help of accuracy underscore score, the technique which I have imported earlier. With the help of that technique I am going to calculate now. So accuracy underscore score I am calling. The first parameter which it will take is y test, that is my actual output, comma ypred1, that is the predicted output from logistic regression. So this how accuracy score will predict the accuracy means it is going to compare actual and predicted output, and it will give some accuracy score like decimal floating value in between like 0 to 1, 0.13, 0.6, some values it will give. That value I will store it in a variable acc. Finally I want to print accuracy in percentage and up to 2 decimal values I want. So print of accuracy of logistic regression, wherever the flower base is there at that place only accuracy will be replaced. I want up to 2 decimal point, so colon dot 2f will restrict accuracy up to 2 decimal point. Finally adding the percentage symbol, so I want accuracy in percentage, so dot format of accuracy acc1 I'm multiplying it by 100 in order to get it in percentage. So finally these two lines will print the accuracy in percentage of logistic regression. So this what I did for logistic regression I will do for the rest of the 6 algorithms. So next, accuracy score of y test 1, ypred2 is nothing but predicted value from random forest. Like that I'll print the accuracy of random forest, knn, decision tree, Gaussian naive, svc, xgb. So all the 7 algorithms accuracy are calculated and printed now. So next thing is when I run the program I will get the accuracy of all the 7 algorithms. Now observe here, accuracy of 7, all the 7 algorithm. Now accuracy of logistic regression is 85.25, accuracy of random forest is 91.80, accuracy of KNN is 65.50, decision tree is 78.69, Gaussian naive is 90.6, SVC is 86.89, XGB is 86.89. So among all the 7 algorithm, random forest is giving the more accuracy of 91.80%, is nearly 92% accuracy it is giving. So among all the 7 algorithm, random forest is the algorithm which gave the more accuracy. Now what I will do means, whichever the algorithm that is random forest gave the more accuracy, I will convert into binary, that is a pickle model, so that I can directly load it in the front end code. So how to convert into pickle model means, import job lib. So with the help of this job lib only I will convert. So joblib dot dump of which algorithm I am converting is random forest. So model 2. Observe here, model 2 is nothing but my random forest. So only I am converting, that gave the more accuracy. Model 2. The file name I am giving is hard disk. The extension should be pkl here to give. So whatever the name you want, you can give here. So just now I am giving hard disk is extension pkl. So the after executing this thing, and a hard disk is pkl file will be generated automatically. So now you can observe, whatever this hard disk is pkl you are seeing here, it will automatically generate after executing this particular line. So after doing this one, whether the conversion is made successfully or not, in order to cross check, what I will do is, again I will load it back. So how to load it back means, joblib.load. So the name of the file is hard disk is dot extension pkl. It will load the algorithm back. I will store it in a variable final model. So now I will predict the output from this one. So final model predict x stage. Finally I will store in pred. Now I will calculate the accuracy of this one. So accuracy score of y test and y pred store in ICC. Finally accuracy of my final model is up to 2 decimal point I will print. So now you can check what is the accuracy I am getting. So accuracy of my final model is also 91.80, which is same as random forest classifier. So this means nothing but whatever the conversion I did, I load it back and I checked again. So the conversion is done successfully. So now I got algorithm which gave the more accuracy. I converted to binary format successfully. That is PKL model. So next thing is, all the 7 algorithm accuracy I am getting. Just now I will create one more bar plot where just to print the accuracy of each algorithm. So I will create one list now, scores, where in that one all the accuracy will be stored in a list. So ACC 1 to ACC 7, all the 7 algorithm accuracy I will store in this list. So now one more list I will create. Well, the algorithm names I will add. So algorithms is equal to logistic regression XGB classifier, respective algorithm name had added. So now I will create one graph for these values. So SNS I am using cbone.set RC figure size, you can set here. Figure of figure size, see height and width 15,8 I am setting. The x label, in the x label algorithms will be present. So plt.x label I am writing algorithm. In the y axis we'll have x axis algorithm will have, in the y axis will have accuracy score. So plt.y label I am giving accuracy score. Finally in order to plot the graph, sns dot I am drawing a bar plot. So sns dot bar plot of for which values means this algorithm and score. So in the x axis will have algorithm, in the y axis will have accuracy. Finally to show the graph output, plt dot show I am doing. So when you draw this one, this is the final graph you are getting for the accuracy. So observe here, for logistic regression it is giving 85 something. So these values accuracy in between 0 to 1 only. So 0.8 is later you can multiply 100 in order to get it in percentage. So 0.8 is nothing but 80%, like that. 0.2 means 20, 0.4 40, 0.6 means 60, like that. For logistic regression, random, KNN, decision tree, naive Bayes, SVC, XGB. Here also you can observe among all these things, random forest is the algorithm which gave the more accuracy, 91.8. You can observe value is 0.918 is nothing but 91.8 accuracy it is giving. So here this class also you can show like store as a image here. So now I will close this one. So you can observe, now I have explained everything whatever there in the backend code. So in the backend code I trained an algorithm which gave the more accuracy. I converted into binary format finally, so that I can load it in the front end. So random forest algorithm gave the more accuracy here with accuracy of 91.80, nearly 92% accuracy it has given. Thank you for watching the video. Thank you.